Welcome to basic integration by parts examples. So recall the rule for integration by parts says that the integral of u dv is equal to u times v minus the integral of v du. So for an example, let's evaluate the indefinite integral, which is the integral of x times sine of x dx. So as a general rule of thumb, our goal is to pick a u that gets simpler as we differentiate. And our second piece of that goal is to pick the dv that at least doesn't get more complicated as we integrate. So for this problem, x gets simpler as we differentiate, and it gets more complicated as we integrate. And the other component was sine of x. Sine of x just goes to positive or negative cosine x, whether we differentiate or integrate. So sine of x goes to plus or minus cosine of x, either way. So it doesn't get more complicated as we integrate. So since sine doesn't really matter either way, and since x does get simpler as we differentiate, we'll go ahead and pick our u to be x, and we'll pick our dv to be sine of x dx. So then integral of u dv is in fact precisely our integral of x sine of x dx, which is what we want. So we can go ahead and apply our integration by parts. So this should be equal to u times v minus the integral of v du. So we need to know u and dv. Sorry, we need to find v and du. So we know that dv is sine of x dx. So v should just be equal to the integral v should be equal to the integral of sine of x dx plus or minus our c. And so we get that v, integral of sine, is a negative cosine of x. So we can take v to be negative cosine of x. On the other hand, u was equal to x. So du is just the derivative of x, which is 1, times dx. So du is just dx. So at this point, we have that our integral of x sine of x dx is equal to, we should do a u times v. So we are looking at x times a negative cosine of x. Then we should subtract the integral of v du. So we are looking at minus the integral of v is a negative cosine of x. And du was just dx. At this point, we can go ahead and finish off. So we have a negative x cosine of x. We have minus and negative becomes plus. The integral of cosine is just sine of x. And then of course we have plus c. So we have that the integral of x sine of x dx is simply negative x cosine of x plus sine of x plus c. Next up, our next example, let's go ahead and evaluate the definite integral from 2 to 3 of x e to the x dx. We are going to do this in 2 steps. The first step is to find the antiderivative, or find an antiderivative. The second step will be to perform the definite integral. So for our antiderivative, let's just go ahead and look for the indefinite integral of x e to the x dx. So in this case, we will go ahead and pick our u to be x. Again, x gets simpler. Sorry, so we'll pick our u to be x. We'll pick our dv to be e to the x dx. Again, in this case, u gets simpler as we differentiate. Versus dv gets no more complicated as we integrate. So next thing we need to do is we need to find v and du. So of course, our dv is e to the x dx. That means that our v is an integral of e to the x dx. So v is just e to the x. On the other hand, u was equal to x. Differentiating, we get that du is simply equal to dx. So plugging into the formula, we have that the integral of x e to the x dx is equal to, we do u times v. So we have our u was x, v is e to the x. So we have x times e to the x. Then we subtract off the integral of v du. So we are subtracting off the integral of e to the x dx. This becomes x e to the x minus e to the x plus c, since the integral of e to the x dx is simply e to the x. So we can pick an antiderivative, x e to the x minus e to the x is an antiderivative. Next up, we're going to apply the fundamental theorem of calculus to find the definite integral. So the definite integral we were looking for was the definite integral from 2 to 3 of x e to the x dx. So this definite integral from 2 to 3 of x e to the x dx, this is equal to, we found our antiderivative to be x e to the x minus e to the x. And we will evaluate that at 2 and 3. So this becomes 3 e to the 3 minus e to the 3 is plugging in 3. Then we will subtract off in brackets 2e squared minus e squared. So we are looking at 2e cubed minus e squared. And that is our definite integral. So this is how we can perform integration by parts. In the next video, we will look at an alternate format, which is a bit of a shorthand notation that I find useful and is what I usually use for integration.